Welcome to the deep dive. So our mission today is to unpack this. Honestly, it's a completely wild juxtaposition that we found buried inside a late February 2026 industry brief.
Yeah, from Kinsoft Tech Talks,
Right, exactly, from Kinsoft. And we're basically looking at this snapshot of just a single week in the tech sector, and the contrast is, it's genuinely mind-bending.
It really is.
Because on one side of the ledger, you've got these tech giants, rolling out hyper-advanced, totally autonomous AI systems that are like verging on science fiction.
Oh, absolutely. Stuff we couldn't imagine 5 years ago.
Right. But then on the exact same page of this report, we're seeing these massive, catastrophic data breaches causing just absolute chaos. And they're all triggered by vulnerabilities so basic they barely even qualify as hacks.
Yeah, and I think it's a critical dynamic for you to understand right now as you're listening to this.
Definitely.
Because, whether you're an enterprise engineering lead trying to architect a secure AI rollout for your company, or just a regular user trying to ensure your personal financial footprint isn't scraped and sold on the dark web.
Which is all of us, basically.
Right, exactly. Understanding how these two extremes collide, it's probably the most important navigation skill you can have in the current tech landscape.
For sure. And to put this into perspective, imagine you're in your garage building a car.
Right. Okay, I'm with you.
And you somehow manage to acquire this million-horsepower, state-of-the-art experimental jet engine. And you strap it directly onto the chassis.
Bolt it right on.
Bolt it right on. And the engineering is flawless, right? It can take you anywhere instantly. But then you step back to admire your work, you look at the doors, and you realize the locks on this magnificent machine can still be picked from the outside with, like, a rusty paperclip.
The jet engine next to the paperclip lock, it's such a perfect analogy.
It's crazy, right?
It is. You have the absolute pinnacle of machine reasoning layered directly on top of these glaring, primitive structural vulnerabilities.
Yeah. So let's start with the jet engine side of the equation first, because late February was, it was an absolute arms race.
Oh, it was a wild week.
Right. The Kinsoft brief highlights these three massive updates hitting the industry practically at the exact same time. We've got Google, Anthropic, and OpenAI. Let's start with Google dropping Gemini 3.1 Pro in preview.
Yeah, that was huge.
So a 0.1 release in machine learning usually implies like a major architectural flex, right?
Yeah.
Not just a simple fine-tuning pass. So what is actually happening under the hood there?
Well, the 0.1 designation here signals a really significant evolution in how the model routes information.
Okay.
They aren't just scaling up raw compute, they're refining the underlying architectures, likely leaning even heavier into what we call advanced sparse expert models.
Sparse expert models. So what does that mean in plain English?
Right. So instead of activating the entire neural network for every single query, which is, computationally ruinous and super expensive.
Like turning on all the lights in a skyscraper just to read a book in one room.
Exactly. Great way to put it. Instead of doing that, the system dynamically routes your prompt to highly specialized subnetworks.
I see.
And the result is what they're calling class-leading benchmark scores achieved with just far better inference efficiency.
Wow. And the headline feature they attach to this efficiency is that 1 million token context window.
Yes, the million tokens.
Which is wild. And we'll get back to why that specific number is actually so dangerous in a minute. But first, let's look at how Anthropic responded. Right on Google's heels, they shipped Claude Sonnet 4.6.
Yeah, they didn't waste any time.
No time at all. And Sonnet is historically their middle-tier model, right? The one that optimizes for speed and cost.
Exactly.
But with 4.6, they pushed this massive upgrade specifically targeting coding capabilities and these long, multi-step tasks, and they kept the price exactly the same.
Which is the craziest part to me. The mechanism driving that price-to-performance ratio is fascinating.
How do they even do that without burning cash?
Well, to boost reasoning on those long, multi-step tasks without raising the API cost, you have to drastically optimize the working memory. It's what's called the KV cache.
The KV cache, okay.
Yeah. So Anthropic basically managed to compress how the model stores the history of the conversation.
Oh, I see.
So this allows it to maintain a really deep understanding of complex code bases without requiring this massive, expensive spike in compute for every single new turn of the conversation.
Okay, that makes sense. So they're just getting way more efficient with the memory they already have.
Exactly.
And then, okay, we have OpenAI. And the Kinsoft brief points out that they took a totally different angle that week. Instead of dropping a massive new model, they made a really strategic acquisition of human talent.
Yeah, this is a massive signal to the market.
Right. They hired the creator of this massively popular open source project to lead their push into what they explicitly called next generation personal agents.
Yeah, and the focus on the open source community here is the absolute tell.
How so?
Well, over the last 2 years, while the big labs were focused on building the underlying foundational models, like the raw brains, the open source community was busy perfecting the orchestration layer.
Okay, the orchestration layer. Meaning what exactly?
They were the ones figuring out the scaffolding.
Yeah.
Like how to take a raw language model and actually give it tools, give it memory, and give it agency.
Oh, right. So it can actually do things instead of just talking to you.
Yes, OpenAI bringing in that specific talent signals a huge structural pivot. They realize that the raw intelligence of the model is no longer the primary bottleneck.
Right. The models are already smart enough.
Exactly. The bottleneck now is the framework that allows that model to interact with the external world seamlessly.
Which brings us to the giant neon sign flashing over all three of these updates, which is the word agent.
Yep, the era of the agent.
The Kinsoft brief is just adamant about this. The era of the passive assistant is completely over. We are now in the era of the agent. So for someone who has spent the last few years treating AI like an incredibly smart answering machine, what's the actual mechanical shift happening here?
So think about an assistant. An assistant operates in a closed loop initiated by the user.
Okay.
You send a prompt, it retrieves or generates data, it outputs text, and then it just stops. It waits for you to drive.
Like a search engine on steroids.
Exactly. But an agent is asynchronous and goal-oriented. You give it an objective like, audit our vendor software spend for Q3 and highlight discrepancies.
Wow, okay.
Right, and it breaks that big goal into smaller tasks on its own. It generates a plan, writes a script to query the database, reads the output, realizes a data field is missing.
And it fixes it.
Yes. It accesses a secondary API to pull the missing data, compiles the report, and then emails it to your team. It executes an entire operational loop all on its own.
That is just wild. And this connects directly back to my earlier question about Google's 1 million token context window. Because we hear these massive token counts thrown around constantly.
Right. It's the favorite marketing metric right now.
Exactly. But I want to look at the actual utility of this for you, the listener. What does 1 million tokens allow an AI agent to do that a smaller context window prohibits?
That's the key question.
Because, I mean, if an assistant just needs to summarize a thick PDF, sure, a big window is great. But for an active agent, is it just about reading more text, or is this about maintaining a chain of actions without losing the plot?
It is entirely about maintaining state over a prolonged period.
Oh.
So think of the context window not as a bookshelf where it stores information, but as the physical desk where the agent is actively working.
Okay, the physical desk. And 1 million tokens means a massive desk.
A desk roughly the size of a football field.
Oh.
Yeah. If an agent is executing a really complex task that takes, say, 4 hours, it needs to keep the original instructions, the API documentation for the tools it's using, the intermediate code it just wrote, and the error logs it just generated, all spread out on the desk at the exact same time.
Right. It needs to see all of it at once.
Exactly. If the context window is small, the desk is tiny. The agent has to constantly throw old documents in the trash just to make room for the new ones.
And then suddenly it forgets why it was querying the database in the first place.
Precisely. It suffers from context amnesia.
Context amnesia. That's a great term for it.
Yeah, it starts hallucinating variables or repeating the exact same error loop because it dropped the initial instructions out of its working memory.
I've actually seen that happen with older models. It just gets stuck in a loop.
We all have. So a 1 million token window means the agent can hold the entire sprawling history of a massive multi-step task constantly accessible in its active mind. It can execute sophisticated workflows over days without losing its train of thought.
Which is incredible. We are building autonomous systems capable of roaming through our digital infrastructure, making decisions, writing code, moving files. I mean, this is the 1 million horsepower jet engine.
It really is.
But here is the hard pivot in the Kinsoft briefing. And this is where things get incredibly precarious.
Yeah, this is the scary part.
Right. Because if an agent is going to execute these complex tasks for you, it requires access. It needs read and write permissions to your sensitive company databases. It needs access to your personal financial accounts.
It requires the keys to the kingdom. You are literally delegating authentication to a machine.
Delegating authentication, yeah.
And as the brief points out, if you're handing over the keys to highly capable autonomous systems, you have to look very closely at the actual structural integrity of the locks.
Which drags us right into the second half of this briefing. And I'm just going to say it, this is the absolute basement of digital security.
It's grim. It really is.
Because while the major AI labs were shipping these world-changing updates, the exact same week was dominated by a series of catastrophic data breaches.
Right.
And the contrast is just stark because the threats described here are shockingly unsophisticated. Like, let's look at the first case study Kinsoft highlights. This is Figure Technology, a major fintech lender.
Yeah. So Figure Technology disclosed a breach that exposed the personal data, meaning names, addresses, dates of birth, of roughly 967,000 customers.
Almost a million people.
Almost a million people. Now, when we hear about a fintech platform getting breached, the Hollywood assumption is, a highly sophisticated zero-day exploit bypassing layers of advanced cryptography.
Right, like some elite hacking syndicate tunneling through the firewall with custom malware, green code scrolling down the screen.
Exactly. But the reality is just painfully mundane. The breach was executed by the Shiny Hunters extortion crew, and their primary vector wasn't a zero-day exploit, it was social engineering and compromised credentials.
Okay, so this is basically the digital equivalent of a con artist.
Essentially, yes.
They aren't cracking the vault. They're just wearing a high-vis vest, holding a clipboard, and walking up to the front door, and someone inside the building literally holds the door open for them.
That is exactly what happens.
But wait, how does this actually work at scale? Because if a company like Figure Tech has modern security in place, how does a crew like Shiny Hunters actually bypass the authentication? Don't they have safeguards?
They do, but attackers rely on mechanisms like adversary in the middle or ATM architecture.
ATM. Okay, break that down for me.
So they don't just ask for a password, they set up a reverse proxy server. When an employee is tricked into clicking a phishing link, say, an urgent text message that looks exactly like it's from their IT help desk.
Which happens all the time.
All the time. So the employee clicks it, and they are routed through this proxy. The employee types in their credentials, and the proxy intercepts them.
Oh, man.
But more importantly, when the actual corporate server sends back the session cookie to validate the login, the proxy steals that session cookie too.
Wait, so they bypass multi-factor authentication completely?
Yeah.
Like, the system thinks the hacker is the verified employee who just successfully completed the MFA challenge?
Exactly. It exploits the human psychological response to urgency, capturing the authenticated session without ever needing to break the underlying encryption.
That is terrifying.
It is. And we see this exact same reliance on human vulnerability in the second major breach, the brief highlights, which targeted France's national bank account registry.
Right. And this is a nation-state level target. Data tied to roughly 1.2 million accounts was accessed. And again, this wasn't some sophisticated cyber weapon taking down the mainframe, right?
Nope. The registry was compromised using a single government employee's stolen credentials.
A single employee? I mean, how does one compromised login expose over 1 million bank accounts? That implies an incredibly flat network. Like, if I steal a bank teller's badge, it shouldn't give me access to every safe deposit box in the country.
Yeah, that is the core architectural failure right there. It is a total lack of data compartmentalization and a failure to implement a zero-trust architecture.
Zero trust. We hear that buzzword a lot.
Yeah. In a legacy system, once you pass the perimeter, once you log in, the system just assumes you are trusted and grants broad lateral access.
So you can just roam around the network.
Exactly. Zero trust, by contrast, operates on the assumption that the network is always hostile. It requires continuous verification.
So it's always asking, are you sure you're allowed to be here?
Yes. If a mid-level government employee suddenly attempts to export a database of 1.2 million accounts, a zero-trust system flags that anomaly and requires secondary out-of-band authorization.
Right, it stops them in their tracks.
Exactly. The fact that the data was exfiltrated using basic credentials shows that once the attackers were inside, there were absolutely no internal blast doors to spank them.
Wow. So we have two massive breaches, nearly 2 million people exposed. All because of the paperclip lock, right? Someone handing over their password. But the Kinsoft brief includes a third incident from that same week, PayPal.
Ah, yes. the PayPal incident.
And this one is different, right? Because it doesn't involve a stolen credential or an extortion crew like shiny hunters.
Right. So PayPal disclosed that a software bug in their loan application flow quietly exposed personal data for months. There was no active manipulation of an employee at all.
So how does a bug like that just sit undetected on one of the largest payment platforms on Earth? I mean, for months.
Well, while they didn't release the exact technical postmortem, issues like this almost always stem from BLA vulnerabilities.
BLA.
Yeah, broken object level authorization.
Okay, broken object level authorization. What is that?
So in modern applications, your front-end web browser constantly communicates with back-end servers through APIs, right?
Yeah.
A BOLA vulnerability happens when the API endpoint doesn't properly verify if the user requesting the data actually has the authorization to view that specific data.
Wait, so the system checks that you're logged into PayPal, but it forgets to check if you actually own the specific loan application you're asking to see.
That is the exact mechanism.
Yeah, seriously.
Yes. If a developer just forgets to write the specific line of code that matches the user ID to the document ID on the back end, a user can simply modify the application number in the URL, and the server will happily serve up someone else's sensitive financial data.
Because it's an exposed endpoint.
Exactly.
So it's the equivalent of like building a bank vault with 3-foot thick solid steel walls, but forgetting to actually install the hinges on the door. It just falls over if you lean on it.
That is unfortunately a very accurate way to describe it.
Man. Okay, so we have this Kinsoft briefing advising the entire tech industry, and they are analyzing AI agents that can hold 1 million tokens in working memory to execute code while simultaneously watching massive databases get cracked because a developer missed an API authorization check or a government employee clicked a bad link on their lunch break.
It's quite the paradox.
It's insane. Given this reality, what is their actual advice? How does an organization defend itself in a threat landscape that relies on such low-tech methods?
Well, the briefing's advice is incredibly grounded, actually. Because the vulnerabilities exploit basic structural and human flaws, the defense doesn't require futuristic next-generation technology.
Oh, really?
Yeah. The heavy lifting comes down to basic digital hygiene, specifically multi-factor authentication and the rigorous handling and compartmentalization of personal data.
Okay, I have to push back hard on this. Every single person listening right now knows what MFA is.
Of course they do.
Every IT department on Earth beats the drum of basic hygiene and zero trust. If MFA and data compartmentalization do the heavy lifting, and the entire industry already knows this, why are massive organizations like a national government registry or a giant fintech lender still leaving themselves completely open? Are we just structurally lazy?
It isn't laziness, actually. It is the inherent friction between security and enterprise velocity.
Friction versus velocity. Okay.
Security, by its very nature, introduces roadblocks. Multi-factor authentication is friction. Compartmentalizing data so an employee has to submit an IT ticket just to access a database that is friction.
Yeah, and nobody likes filing IT tickets.
Right. And in fast-paced environments, whether you're a booming fintech startup rushing to deploy new features or a sprawling government agency handling thousands of requests a day, friction is viewed as the absolute enemy of productivity.
People just want to get their jobs done without authenticating for the 12th time before lunch.
And extortion crews weaponize that exact fatigue. They execute what's called MFA prompt bombing.
Oh, I've heard of this.
Yeah, they send continuous authentication requests to an employee's phone until the employee gets so annoyed they finally just click approve to make the notification go away so they can get back to work.
Which is just classic human psychology.
True security against these attacks requires hardware keys, like FIDO2 compliant physical tokens, which eliminate the vulnerability of those ATM proxies we talked about.
Oh, right, because the physical key proves you're really there.
Exactly. But deploying physical hardware keys to thousands of employees is expensive and logistically complex. So organizations settle for less secure app-based MFA. They accept a lower security threshold in exchange for higher operational velocity.
Which makes human error the persistent, unpatchable weak link in the entire infrastructure. I mean, you can have the most sophisticated encryption algorithms on the planet, but if a fatigued human has the authority to bypass them, the human becomes the attack vector.
Unfortunately, yes.
And this brings us to the Kinsoft sign-off, which is remarkably succinct. Their final advice to the industry is simply to stay patched, stay skeptical.
Yeah. Stay skeptical is basically the psychological firewall. It is the only immediate defense against social engineering.
Just trusting your gut when something feels off.
Well, more than that, it's the conscious insertion of friction back into the process, like pausing to verify out of band if the IT department is actually requesting a password reset.
It's demanding to see the ID badge of the guy in the high-vis vest instead of just assuming he belongs in the server room.
Exactly. And staying patched directly addresses the PayPal scenario. It is an acknowledgement that modern applications are incredibly complex, and things like Bolay vulnerabilities and exposed API endpoints will occur.
Because humans write the code, and humans make typos.
Right, so it requires automated, rigorous auditing of code bases to catch those structural errors before they sit exposed to the public internet for months on end.
All right, let's pull this all together. Our mission today was to unpack this juxtaposition in the Kinsoft Tech Brief, and we're looking at two entirely different realities colliding here.
Yes, head on.
On one side, we have this AI arms race pushing the boundaries of machine capability. You've got Google deploying Gemini 3.1 Pro with MoE architecture and a million-token memory disk.
Football field desk.
Right. Anthropic optimizing the KV cache in Claude Sonnet 4.6 for complex coding tasks. OpenAI pivoting their entire corporate structure to build next-gen personal agents. We are officially in an era where AI doesn't just retrieve information, it actively navigates our digital infrastructure to execute prolonged tasks.
The capabilities are scaling exponentially.
Yeah.
And we are eagerly handing these agents the keys to our most sensitive data to unlock that productivity.
But then, on the exact same day, we are reminded of the stark reality of how we protect the infrastructure those AI agents are interacting with. Figure Technology and the French bank registry were breached not by supercomputers breaking cryptography, but by stolen passwords and proxy servers exploiting human psychology. Yep. PayPal exposed data because of a missed authorization check on a back-end API. As we build AI agents capable of incredibly complex reasoning, the security perimeter defending our digital world remains entirely dependent on humans not falling for a phishing text.
We are trusting highly advanced automated systems to handle our data, while the perimeter defending that data is guarded by human fatigue and basic software configuration errors.
It fundamentally changes how you look at that million-horsepower jet engine strapped to the chassis. I mean, if we are going to travel this fast, we urgently need to re-engineer the door locks.
We do. And, following the logic of these two trends colliding actually raises a deeply provocative question regarding the future of enterprise architecture.
Oh, where does this inevitably lead?
Well, consider the core vulnerability here. It's human error, right?
Yeah, always.
A government employee authorizing a malicious proxy because they were suffering from alert fatigue. A rushed programmer missing a Bolay vulnerability in a massive code base. Humans are consistently the weakest link because we get tired, we take shortcuts to maintain velocity, and our attention spans degrade.
We're only human.
Exactly. But simultaneously, we are perfecting autonomous AI agents that never suffer from alert fatigue. They cannot be socially engineered over a phone call, and they can analyze millions of tokens of code to identify unauthenticated API endpoints in seconds.
Oh, wow. I see where you're going with this. We are building the exact system needed to counter the human flaws.
Think about it. If human friction is the vulnerability, and these new AI agents are the solution for executing complex digital governance flawlessly, the ultimate end state of this arms race might be using these exact agents to lock humans out of our own security infrastructure entirely.
Great, lock us out entirely.
Yes. If the AI agent is smarter than the extortion crew, and it's more meticulous than the human developer, the most secure architecture moving forward might be one where humans are no longer permitted to hold the keys at all.
That is wild.
Access controls, database routing, code audits, all of it could be entirely governed by agentic AI, removing the human bottleneck and the human vulnerability completely.
So to fix the rusty paperclip lock, we just take the doors off entirely, weld the chassis shut, and let the jet engine drive itself.
Heard about.
We build the perfect machine, and then we have to remove ourselves from the loop so we don't accidentally compromise it. That is a heavy concept to leave you with, but an essential one as we navigate this wild transition from passive assistance to autonomous agents. Stay patched, stay skeptical, and pay very close attention to who or what actually holds the keys to your data.